Hello, welcome to another edition of GRUR, Geography Revision Rocks. Behind me is a beach, and for our exam we need to know some of the things that might happen on that beach. But before we start, what did the sea say to the beach? Nothing, it just waved. So, for our exam, what do we actually need to know about the beach and what might happen there? Well, I think for that we're going to get a little bit closer. So, just watch this little bit of magic.
Well, the first thing you'll notice is that this part of the beach is much higher than this bit of the beach here. So why is this bit of beach much lower on this side of the rock groin than the other? Well, to find out, we're going to go down a little bit closer to those waves. So the reason this bit of beach is lower than the other side of that rock groin, which you can't see behind you, is because of a process we call longshore drift. And longshore drift is the movement of sediment from one part of the coastline along the coastline. So how does longshore drift work? Well, for that we need three key ingredients. Number one, we need something called the prevailing wind. We also need the waves to come in at an angle determined by the prevailing wind called the swash. And we also need the waves to go back, which is called the backwash.
So if I was to draw a diagram of what I've just been talking about there, I could make the diagram really simple. First off, I'd want to show the examiner the difference between the land and the sea. And I know that sounds obvious and silly, but it's important the examiner knows that we know which is the sea and which is the land. So this line here is our beach. The other thing we need is the prevailing wind. And that can be here, and we need to label it. And remember, the prevailing wind for longshore drift to occur has to hit the beach at an angle. And that prevailing wind will determine the swash, so that's the direction of the beach diagonally up the beach. And then the backwash comes straight back down due to gravity. And then that process continues, so the swash goes up diagonally, and then the backwash goes straight back down due to gravity. And if you're not sure what going straight back down due to gravity, here's what it looks like. And as the process continues, as the swash goes diagonally up the beach, the backwash goes straight back down due to gravity, the sediment, our pebbles or sand, is going to be moved along the coastline. So on our diagram, we'd also want to put the direction of longshore drift, just to show the examiner that we understand which way longshore drift is going. So on my diagram, I'm just going to put direction of LD, but that means longshore drift.
So we've seen what longshore drift looks like in a diagram. Now let's have a look at how that process moves sediment along the coastline. Remember, the swash, determined by the prevailing wind, goes diagonally up the beach, backwash straight back down due to gravity.
Behind me is another exam question, and you'll notice that it doesn't mention anything about longshore drift. However, for a question like that, we need to know a little bit about it. So, as ever with a formation question, I always think it's a good idea to draw a diagram. So, I'm just going to go off now and show you how to draw a diagram. So, for an exam question like that, the first thing we need, even though it doesn't mention longshore drift in the question and it talks about the formation of a spit, we must have longshore drift to occur for the spit to form. So the first bit of our diagram is going to be the same diagram we drew earlier, so it's just going to be that diagram of longshore drift. But for a spit to form, something else needs to happen, and that is when the land changes direction. Now when the land changes direction, longshore drift is going to continue. Okay, so the swash goes diagonally up due to prevailing wind, the backwash comes straight back down due to gravity. And because the land has changed direction, the sand and pebbles aren't going to follow the coastline around. They'll continue, the sand will continue to move along here, and it will start to get deposited. Right, so it will start getting dropped. And as more and more of it gets deposited, we end up getting a finger of land. The beach grows out from the coastline and it sticks out from the land like that. That's what we call our spit. And what can happen at the end, it can sometimes be curved in. And the reason it's curved in is there could be a storm force wind that might come from this direction. And the posh word we might use for that is recurve laterals. But for the question we've got, or we had behind me just then, you could probably just talk about longshore drift and talk about the sediment being deposited because of the change in the shape of the land. That's important. And what I'll do now is I'm going to show you the sentences that you would put in to get top marks on that question to accompany this diagram. For a spit to form, you need longshore drift. The prevailing wind will push the swash diagonally up the beach. The backwash comes straight back down due to gravity. This process repeats and sediment moves along the coastline. If the land changes direction, sediment will continue to be deposited and a spit will form. Over time, the spit will get bigger. At the end, it will sometimes curve in if the waves come from another direction. Job done, maximum marks. Well, thank you for listening to another edition of Grua Geography Revision. Hello, come in.
Mr. Spencer, hello.
Hello, Mr. Greenwood. Do you know what? You knocking the door has just reminded me of something. Knock, knock.
Who's there?
Sandal.
Sandal who?
Sandal get in your shoes if you walk on the beach. Okay.